Good morning, everyone. We will be looking at units 1, 2, 3, and 4 through YouTube, and after that, we'll probably meet through Zoom moving forward. So expect that in the meantime, we will be meeting in YouTube live stream videos, okay? All right, on that note, let's take a look. Unit 1 notes. Let's start with the thing that we love the most, and that is fractions. No, we really don't love them, but I really wish that we did because, I want you all to be super comfortable with fractions. I also want you guys to realize that we will be looking at fractions probably every single class session that we meet. So the sooner you enjoy fractions, the sooner you're able to work with them and perform operations using fractions, the better off you are. So make sure that you are working on this diligently. As a little side note, you should have index cards. If you struggle to kind of think about what the rules are for fractions, addition, subtraction, multiplication, division, create index cards. Create index cards that have the rules there and just keep playing until it's second nature, okay? It might help. You never know. Okay, going back, let's take a look. Reducing fractions. So when we think about reducing fractions, we think about the word simplify. The idea of simplifying a fraction or reducing a fraction is essentially making sense of what it means to find factors that are common to both the numerator and denominator. Of a fraction. Please don't say top part and bottom part of a fraction. Let's use a correct terminology, numerator and denominator. Once you find that factor that is common to both the numerator and denominator, you are then going to divide this number out of each. I want to point out to you all that you really can do this piecemeal, meaning if you know for certain that there's a factor that goes into both your numerator and denominator, but you're not certain that it's the greatest common factor, that's okay. You can do this in steps. You can break a fraction down bit by bit if that's helpful. Nobody's going to judge you for not finding the greatest common factor and dividing it out. I will tell you that's the easiest, right? It's the quickest, that's what I mean. It's the quickest way to reduce a fraction, but sometimes you can't find it, and that's okay. It's not a big deal. Not a big deal at all right? So I'm going to write here, note, sometimes identifying the GCF, the greatest common factor, would be the most helpful. I say sometimes because I don't want you to sit there trying to find the GCF and just like spending 5-10 minutes doing that. You don't need to do anything overkill. So let's take a look at our first example. We have 35 over 115. Right off the bat, can you guys throw in the chat what your common factor is for 35 and 115? Throw that in the chat really quickly. Let's test this out. Yes, Patrick started us off. He said, let's divide by a 5, and I totally agree. If it helps, you can write out that we're dividing both the numerator and denominator by 5. Yes, Amanda. Yes, Doc, Claire, Hannah, perfect. We're going to divide both the numerator and denominator by 5, and that leaves us with 7 over 23. Excellent. Rachel, Ashanti, Alexis, beautiful. So notice here with the 7 over 23, we recognize that we're not going to be able to divide further. Our numerator is smaller than the denominator, and the factors of our numerator are 1 and 7, right? 7 cannot go into 23, so we are not worried about having to reduce anymore. I would urge you not to convert your fractions into decimals throughout this class unless otherwise specified. The caveat to this is if your word problem or problem starts with a decimal, your answer can be a decimal. But if it does not, err on the side of fractions as your answer if it has to be in a fraction form. Take a look at 242 and 376. What do you think is a factor you can divide out of these two? Yes, Kayla, 2 is correct. We're not going to overthink it. We're going to look at both of those numbers and we're going to say, let's divide out a 2 from both. Yes, perfect. Yes, Maria, Hannah, Ethan, Ashanti, excellent. We're going to divide a 2 out of both. When we divide a 2 out of both, that leaves us with 121 over 188. But can this be reduced further? I want to show you a trick with the calculator. So for this class, we will be using a TI-30X2S. Give me one second. So for this class, we're going to be using a TI-30X2S. And I want to show you what you can do with this calculator to determine whether or not you need to reduce further. Sometimes I would like you to consider your calculator as simply a tool to ensure that you're getting the correct answers. I don't want you to rely on the calculator. That's a hugely different experience. I have found students rely on the calculator so heavily that the answer could not possibly be correct, but because the calculator said so, they wrote it down and they said, this is the answer. And that is not okay. You must be critical learners. You must think about the answers that you are producing and make sure that they make sense. So let me show you a neat feature that this TI-30X2S has. So first off, we had 242 over 376. Check this out. You're going to type in 242. Then you're going to press this ABC key. I hope you all can see that. If you press the ABC key, it tells your calculator that you're inputting a fraction, where 242 is your numerator, and then you separate it and you say that 376 is your denominator. Now, after I input my fraction, I press enter, I press equals, and it reduced it for me. And it reduces all the way. There are some calculators that you have to keep telling it reduce, reduce, reduce until it finally gets to its most reduced form. Well, this one, the TI-30X2S, will go all the way essentially. So we see here that 121 over 188 is in fact the reduced form. We could try that again with the 35 over 115. Take the 35, press the ABC key, and type in the denominator 115. And voila, 7 over 23. So it's a really, really great tool to use to kind of help you to make sure that you've reduced your fraction all the way. Why not punch it in, double check, make sure that it can't be reduced further. Now, in terms of understanding whether or not we can reduce further just by looking at the number, we have some tips for common factors. So any even number will always be divisible by 2. That's a certainty. Any even number will forever be divisible by 2. Any number that ends in a 0 or a 5 is divisible by 5. Think of 5, 10, 15, 20, 25, 30. Those end in zeros and 5s, and they're all divisible by 5. Any number that ends in a 0 is divisible by 10. right? Think 10, 20, 30, 40, 50. They're all divisible by 10. Now here's the one that very few people know. Any number whose digits sum to a multiple of 3 is actually divisible by 3. Now, because so few students in my experience know about this common factor tip, I wanted to show you an example. Take a look at the number 1,680. Okay, we know it's divisible by 2 because it's even. We know it's divisible by 5 because it ends in a 0. We know it's divisible by 10 because it ends in a 0. But what we don't realize is that it is actually divisible by 3. So take a look. 1 plus 6 is 7. 7 plus 8 is 15. 15 plus 0 is 15. Do you agree that 15 is a multiple of 3? Yes, it is. Multiples of 3, I'm going to write those out. So multiples of 3 are 3, 6, 9, 12, 15, etc. Those are multiples of 3. So because your digits sum to a multiple of 3, we know it's divisible by 3. I hope that helped. I think it's a neat trick to kind of think about. All right, next in our notes, we are going to learn how to convert mixed fractions to improper fraction and vice versa. Thank you, Kayla. I thought it was cool too. And when I first learned about that, I was like, oh my God, that's so sweet. I have other tricks to show you throughout the semester that I think you will all really, really, really love. Okay, next, we want to take this 3 1/4, we want to turn it into an improper fraction. Well, here's how we do it. Right, Amanda? Okay, here's how we do it. So you are going to move in a clockwise fashion. You are going to start from the denominator, move to the numerator. So if we're converting from mixed to improper, we're going to move in a clockwise fashion. And how we're going to do that, and if it helps, I'm just going to draw arrows, kind of show that that's what we're doing. We are first going to take our denominator and multiply it by our whole number, and then we're going to add whatever that result is to our numerator. Now, there's a little issue with this. First, let's convert this to an improper fraction, and we're going to double check. So 4 times 3, that's 12. 12 plus 1, that's 13. And obviously, it's a fraction, so we want to keep it out of the 4 parts. Okay, so 13 out of 4. Think about this logically. 3 and 1/4. 3 and 1/4 means 3 and 1/4, right? Because if it was 1/2, it's a half. If it's 3/4, it's 3/4. So 3 1/4, we know, is 3.25. When we make our conversion, it better be the same damn thing. So if you take 13 and you divide it by 4, we have 3.25. So we know for a fact that we converted correctly. Those need to be the same. Now check out, thank you. Now check out your next example here, -8 and 7/9. All right. If we did that again, let's see what happens. 9 times -8, +8. What would you do? Let's test this out. We're going to say, I'm not sure. We're going to say, I don't know if I keep that negative or not. I haven't seen that. I'm going to test it out. So if, and I'm not going to write this down because it's not correct. I'm just going to kind of give you that little surprise right now. So if you took 9 and you multiplied it by -8, so 9 times a -8 gives us a -72, correct? So 9 times -8 is a -72, and when we add the 7, notice we get a -65. If our fractions are equivalent, this should be, quote unquote, should be -65/9, right? Because we keep the denominator. Let's test it. -65/9. Just by looking at this, we have -7.2 repeating. Okay, hold that thought. -7.2 repeating. Whoa. This is a -8 and 7/9. Just by looking at what we have in the calculator and what we have on the paper, we did something wrong. So what we'll do instead is we are actually going to still multiply and still add, but we will not include the negative in our computation. So I'm going to make a little note here. Do not include the negative in your computation. Don't do it. Don't do it. If you do it, you'll get the answer incorrect. And you know, you could always check. So even if you did do it, whatever, you'll check, you'll be like, oh shoot, that's not right. So we do 9 times 8, which is 72. 72 plus 7 is 79. Keep the denominator, which is 9, and make it negative. Now this is negative 8 and 7 ninths. Okay, by the way, there's a little trick with the nines here. Without even punching it into my calculator, I could tell you that this number is negative 8.7777777 repeating. And that's because it's over a 9. One of these days, I'll show you the trick with the nines. It's really, really cool and very surprising. So negative 8.7 repeating, that's what we get here. Let's take the 79, negative 79 divided by 9. Every fraction is a division problem. Negative 79 divided by 9, and ta-da! Don't worry about your calculator rounding. It just says, here's my window. This is as big as I can get right now. And because I don't want to put the dot, 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 the ellipsis here, I'm just going to round that last position. It does not mean that it's a negative 8.778. That's not what it means. It just doesn't show the continuing part here. Okay? Keep that in mind. So, in fact, these two are the same. Okay? Now, let's practice going backwards. So I'm going to start with a 13/4 just so I can show you what that looks like. We already discussed the fact that 13/4, well, that's a division problem, right? That's 13 divided by 4. All right, it's time to do some long division. I don't know when the last time you did long division was, but ta-da, we're back. So 13 divided by 4. Right? 4 is our divisor. We're dividing into the 13. Okay, let's think about this. 4 can go into 13 at most 3 times, right? So 4 times 3, that's 12. So if 4 goes into 13 at most 3 times, and that's 12, that leaves us with, 1 left over, right? Now check this out. When you think about this whole process, you're going to say 4 goes into 13 3 whole times, with 1 left over out of the 4 that we started with. So when we do this conversion, we say, oh yeah, 3 1/4. And voila, we have our original expression. Pretty cool, right? I also want you to notice that we still have this clockwise motion, which I love. I love these patterns in math. I think it's so cool to see that. So here with the mixed fractions, we start at the 6 o'clock and we move up to the 12 o'clock. Well, in proper fraction, we start from the 12 o'clock and we go over to the freaking 9 o'clock. It's so interesting. I think that's so neat. So let's do that for our last example here. We have negative 39 divided by 5, or we could say it negative 39/5. So because this is a division problem, again, just like before, where we do not include the negative in our computation, we're going to do the same thing again. We are not going to include the negative in our computation. So we're going to take the 39 and we're going to divide it by 5. Now think about this logically. How many times does 5 go into 39? At most, we're going to say 7. And we say 7 because 5 times 7 is 35. So it's just about 39, but not quite. Oops, I forgot to write minus up there. So we're going to say, all right, well, 35 is 4 away from 39. And what that means is 5 goes into 39 7 whole times, with 4 left over out of the 5 that we started with. So when we go ahead and write our mixed fraction, we will say 7 4/5 But we do not want to forget that our answer is negative. And that's how you convert from mixed fraction to improper fraction. As a reminder, do not hesitate to ask questions. Kayla, Alexis, that's perfect. Don't hesitate to ask questions. Throw those in the chat. I'd be happy to answer those. I love questions. I hope you can get the sense already that I want to make sure you're understanding every little nuance to all of this. And I hope that you like it. I think it's so cool and neat how numbers work together. And I do plan on showing you that 9's trick. You know, let me just show you now. Let me just show you now. Okay, let me take my scrap paper because you got to see this. This is cool. If you have your calculators with you, good. Look at this craziness. I'm going to put on my notebook. I can't talk. I can't talk. Okay, check this out. So I'm going to show you something super cool with the 9's. And actually, I didn't know this until 2 years ago when I was tutoring my niece in one of her classes. She's taking math and she's like, you know, learning something new. And I was like, oh my God, I had never seen that before. So check this out. Let's say that I write the fraction 5/9. If you take 5/9 and you punch it into your calculator, it'll give you 0.5555555 repeating. Okay? I hope you see that. Notice that only the 5 is repeating, right? Only the 5 is repeating. Okay, check this out. Now let's do, I don't know, let's do 56/9. If you take your calculator, oops, over 99, I'm so sorry. If you take your calculator and you punch in 56 divided by 99, you should get 0.56565656 repeating. Interesting, right? That is kind of freaky. Can one of you give me a 3-digit number and throw that in the live chat? I'll use the first 3-digit number I see. Throw any 3-digit number you want in the live chat. $866. Kayla, I'm gonna no, you'll see the pattern. Yep, I'm gonna leave it 866, but this time it won't be over a 9. It won't be over a 99. It's gonna be over a 999. Are you guys seeing the pattern? Take 866 divided by 999 and oh, what do you know? 0.866866 repeating. You cannot tell me that that is not the coolest thing you have ever seen. And we can go reverse. So for instance, let's say that you have the decimal, let's say that you have the decimal 0. We'll do 3333333 repeating. Do you agree that, let me show that, yeah, right, Amanda? I love it. I think it's so freaking neat. Do you agree that the 3 is repeating? So if the 3 is repeating, you're going to say the 3 is repeating, and there's only one 3, so there should only be one 9. And if you punch in 3 divided by 9, you'll get 0.3 repeating. Now, the only issue is we know 3/9 can actually be reduced. And now it's a common fraction that you've seen many, many times, and that's where it comes from. 1/3 is 3/9, and 3/9 is 0.3 repeating. One last one, because there's another one. Yes, exactly, Kayla. There's another one that you guys see over and over and over, and I just want to show you that one too. You see this one a lot. So you agree here that the 6 is repeating. So because the 6 is repeating, it's 6/9. And we know that 6 over 9 is reducible because we divide a 3 out of both. And voila, we have 2/3, which is another common fraction that you should all be familiar with. So 2/3 is actually 6/9, which is actually 0.6 repeating. I love it. I love it. And now you know how to deal with repeating decimals. Yeah. Yeah. Awesome. All right, let's move to our next page. We are now ready to, yes, Hannah, you have a really good point. You said 33 over 99 or 66 over 99. Yes, absolutely. If you took 33, if you took 33 and you punched it in over 99, I want to show you something. Let me go over to my notes. 33 over 99, look at what it reduces to. 1/3. 66 over 99, look at what it reduces to. 2/3. So you're totally right. Just remember, Hannah, we're always focused on reducing our fractions all the way completely. Okay? So even though it can be that form, which is awesome, I love that you're seeing equivalent fractions here, you really should want to focus on what's the reduced form. Excellent point. I love it. That was beautiful. Very, very nice. Okay, now multiplying fractions. Please, if when you multiply fractions, if you tend to want to like find the LCD, stop yourself. Just say no. No, not when you multiply fractions. I think that's one of the most common errors that I see. I've been doing this for 13 years. That's definitely one of the most common errors I see when students are working with fractions. If you're multiplying, you don't need an LCD. Please, just remember that. That's the one thing I want you to just kind of keep. No LCD, no LCD. I don't need an LCD. So I'll show you the steps when multiplying fractions. The other thing is my advice is reduce up front. I've seen students wait to reduce at the end. It'll work either way, but man, is life going to be miserable if you wait to reduce at the very, very end. So I just want to show you how cool it is to simplify things up front and then multiply. So let's take a look. So step number 1, reduce the numerator for denominator if possible by dividing out common factors. We did that already, right? We learned that on the previous page. Once we reduced everything, we're simply going to multiply from left to right. Remember, when you multiply, you simply move across the numerators and across the denominators. You do not crisscross. We are not talking about a proportion here. You do not cross multiply when you simply multiply fractions. That is only when you have a proportion, and you'll see that later in Unit 1. I put a note here. If you simplified completely before multiplying, then your final answer will be reduced, which is super cool. It saves you a lot of time and effort. So let's take a look at 2/10 times 3/8. Hopefully you all can see that. I don't mind writing it a little bit bigger just so you can see all the different things you can do. So before we even actually do the math, I want to show you all of the paths you can take. The first path, if you saw the fraction 2 over 10, you would say, whoa, that can be reduced. That's definitely a 1 over 5, right? Because you can divide out a 2 from both. So that's one path. Some of you will say, wait a second, the 2 is a numerator, the 8 is a denominator. We're multiplying so we can cancel numerator for denominator across fractions. You're allowed to do this because multiplication is commutative. And we also know that 2 over 10 is the same as 2 over 1 times 1 over 10. Yes, you heard it right. 2 over 10, I'm going to put that at the top. 2 over 10 is the same as 1 over 10 times 2 over 1. Think about what that means. Think about all the possibilities just by looking at a fraction in terms of its parts. So when we look at number 1 and we say let's reduce, we could say let's divide out a 2 from the 2 and the 8 instead of the 2 and the 10. So we have options. I'm going to choose this fraction. We're going to say 2 divided by 2 is 1, and we're going to say 10 divided by 2 is 5. If it helps, you can write a tiny little beep. There we go, divided by 2. You can write that in there, totally up to you. These are your notes. I'm not staring at them. You can do whatever you want. Okay, so we have a 1 over 5 times 3 over 8. If I rewrite that 1 over 5 times 3 over 8, we notice that numerator for denominator, we're good here. 3 and 5, oh no, they don't have any common factors outside of a 1. 3 and an 8, nope, nothing here. 1 and 8, nothing here. Okay, we're done reducing. So that means when we multiply, we just go left to right. 1 times 3, 5 times 8. Done. Do not overthink it. Not bad, right? Not bad. Let's look at number 2. I jump right into something that's a little bit more interesting to really flex your minds. I want you to consider we have 15 over 45 times 22 times 9 over 18. Can somebody throw what your first step might be in the chat? Is there something you want to do first? Is there something that's jumping out at you? Okay, I love it. Hannah says, well, right off the bat, she looks at this 9/18 and she says, psh, I'm going to reduce that. That looks gross. Oh, interesting. Claire says, put 22 over a 1. That is a perfect behavior to get into. Anytime you're multiplying fractions and you have a whole number, write it over a 1. Yeah, Kayla says reduce what's inside the parentheses. I love it. We're going to do all of that. And Maria, you agree with Claire? Yes, we're going to do all of those things at once. So I love all of the suggestions you're providing. First things first, this is a whole number. Every whole number can be expressed over a 1. Do you agree? 22 divided by 1 is still 22. We didn't change anything, so we can rewrite it. Now we have all sorts of fractions here, and we're going to take a look. So you all suggested, let's focus on the fractions within the parentheses. So 15 over 45. I want to challenge you. Yes, 5 can go into both, but think bigger. 15 can go into both. If you're unsure about that, you're like, wait, what? Let me show you. 15 ABC 45. Ooh. 15 divides into both of them. So we're going to say, and if it helps, again, I'm going to rewrite it. So we have 15 over 45 times 22 over 1 times 9 over 18. And so you said, let's reduce within the parentheses. So within the first parentheses was 15 over 45. So we divide both by 15 and we get 1/3. Cool, right? And then we look at the 9/18 and we say, oh yeah, definitely. 9 can go into itself once and 9 can go into 18 twice. So let's rewrite. We have 1 over 3 times 22 over 1 times 1 over 2. But am I done reducing? Rachel, that's perfect. You notice that that 15/45 reduced to a 1/3. But am I done reducing? No, absolutely not. Take a closer look. Remember, when we reduce numerator for denominator, and it's okay if they're in other fractions, as long as the fractions are connected by multiplication. You cannot reduce numerator for denominator across addition or subtraction or division. Okay? The only time you could reduce numerator for denominator across fractions is if you are multiplying them. Please remember that, okay? That's the only time. If you are multiplying fractions, you can reduce numerator for denominator across fractions. Hannah, you're correct. Let's take a look. 22 and 2 reduces, so 2 becomes a 1, 22 becomes an 11. Remember, you're dividing both by 2. At this point, we go straight across. 1 times 11 times 1, 11. 3 times 1 times 1, 3. And we have finished. Your turn. Do number 3. I'm going to give you 60 seconds, starting now. Okay, excellent. So I'm noticing in the chat that we have a lot of you in agreement. So let's take a look and see what we have here. Now, I am going to take my own personal approach. Excellent. Thank you, Patrick Claire. I'm going to take my own personal approach in reducing this because, I mean, I don't see your papers. I don't see your work. I don't see the approach that you took. But I want to show you that even if you and I have a different approach, we're going to get the same answer. So let's check it out. Okay, first things first, I'm going to put this 18 over a 1. Okay, so right off the bat, and you're going to be like, what the hell? So right off the bat, let me rewrite this first. And because multiplication is commutative, meaning the order doesn't matter, 3 times 4 is the same as 4 times 3, I'm actually going to be difficult, and I'm going to say, let's reduce the 16 and the 18, right? I'm looking at this 16, I'm looking at this 18, and I'm saying, okay, well, they're both divisible by 2. So if I took this 16 and I divided by 2, I would get 8. And if I took the 18 and divided by 2, I would get 9. Now, I'm almost like 99% sure that none of you did that as your first step because I'm a weirdo and I've got to make things different. But I like it, and I just want to show you what you can do. It's still numerator denominator, and we're still multiplying, and there's still fractions, so we can do this. Okay, next let's take a look at the 44 and the 14. We know that they're both even numbers. In 14, you can get a 2 and a 7, but we know 7 can't go into 44. So let's divide by 2. So we divide 44 by 2. That leaves me 22. We divide 14 by 2. That leaves us 7. Now, I look at all of my numerators and denominators, and I notice, oh, wait a second. Let me rewrite this so I get a clearer picture. Sometimes, you know, this math can be messy, so it's helpful if we reduce or if we rewrite so that it's clearer. I notice 22 and 8. I can divide both by a 2 again. Let's do it. So 22 divided by 2 is 11, and 8 divided by 2 is 4. So at this point, I'm going to continue to explore here. No dividing, nothing here, nothing here, nothing here. Okay, and yes, thank you, Hannah. So we've got 11 times 3 times 9, and guess what? I've got another trick to show you. So 11 times 3 times 9. 3 times 9 is 27. 27 times 9 is 297. And I did that ridiculously quick in my head, not just because I'm a math professor, but I'll show you how. And then 4 times 7 times 1, well, that's just 28. So you all who said 297 over 28, nice work. That's exactly correct. Beautiful, beautiful, beautiful job. Yes, Kevin. Sorry that's off the screen a little bit. Let me show you the tricks with 11. And then that'll conclude our session real quick. I just told you that 11 times 27 was 297. You know how I know this? Whenever you have a 2-digit number and you multiply it by 11, you're going to take those 2 digits, separate them, and then you're going to add them and put it in the middle. 2 plus 7, 9. Crazy, right? Let's do this again. 11 times, let's do 35. Well, take the 3 and the 5, separate them. 3 plus 5, 8. Is that or is that not the craziest thing you've ever seen? One more. What if you have to carry? Meaning, what if you have something like 11 times, I don't know, 84, right? You still take the digits, separate them. But this time, you know that 8 plus 4 is 12. So check this out. It's a 12, right? You see how I wrote the 12 here? I kind of like put the 2 in the middle and I had the 1 up here. It's a 12. So actually, your answer is 924. Go ahead and verify that. I know. It's ridiculous. It's insane. And now you know how to multiply by 11s without a calculator, as long as it's a 2-digit number. There are patterns for 3-digit numbers and etc. Yeah, it's pretty nuts. But that's it, guys. I kept you for 1 minute too long. This was a fantastic first class. I hope that you loved it too. I know there's a slight lag in when the chat comes in and when the live video is shown, but it's as good as it gets for right now, and I think it's pretty damn good. Excellent. Alexis, great question. From now on, I actually would prefer your answers, if they're fractions, in improper fraction form, not a mixed number. And we'll talk more about that on Monday. Have a good weekend. Bye. Yes. Bye.